Very important test, we need to be able to start the engine under cold conditions, cold as minus 40 degrees.
Removed from its giant freezer, everything must still work perfectly when the engine is started.
We have to make sure that the gearbox will turn when we start the engine. Other tests, so water ingestion.
Water is poured in at 30,000 gallons an hour, but there must be no loss of thrust.
We have to demonstrate that the engine can cope with rain and hail ingestion, and that the compressors can cope with the amount of water going through the engine that it might get in flight, and that the compressors continue to run and that the combustion system remains stable. But one of the key safety requirements we have to ensure we meet is that in the unlikely event of the release of a fan blade, that it's contained by the fan case. Well, it's an absolutely key test in that we need to make sure that there's no chance of the fan blade escaping. On the test, there's an explosive detonation which releases the blade from the disc at max takeoff speed and fires it into the fan case. When this event happens, the energy that's generated by the blade coming off is about the equivalent of a 1-ton car being dropped off a 200-foot cliff. And the casing here then has to retain that and ensure that nothing is released outside of the fan case structure. So it's a hugely expensive test, but our commitment to safety and demonstrating requires us to take that asset and to complete that test, irrespective of what we're left with in the end. The engine is destroyed. Although it's contained the blade and run down safely, the components that are in that engine will not be used again. Effectively, that engine is then written off.
Only by sacrificing an entire engine like this can they be sure the fan case really does its job. It's 6 in the morning and the start of another shift on the assembly line for fitter Andy Taylor.
I just wait round the corner from here, so I work on where they build the stacks. Work 3 shifts, work mornings, afternoons and nights. I'm on mornings this week. Morning. That's the inspection department, very friendly people there. This is my engine for today.
Andy's task today is to fit the first of a network of sensors to the engine.
These are connected to the thermocouples, and these tell the brain of the engine that if there's an overheat problem, it'll tell it to alter something inside the engine to cool it down, or vice versa if it's running too cold.
When it's running, these sensors will measure temperatures, pressures, speeds and vibration at critical points in the engine. The sensors constantly feed that information to the engine's own electronic management system, its brain, that ensures performance is optimised at all times. But it doesn't stop there. Data collected from every Trent engine in the air can even be transmitted via satellite back to Derby. It's received here at the factory's 24-hour monitoring station, manned by senior engineers to keep an eye on Rolls Royce engines all over the world.
Alan, we've got an issue on engine 41992. You can just see that the exhaust temperature's just going up on that engine.
This is 21st century jet engine production, part of a high-tech support package that gives them a commercial edge over competitors.
Increasingly now, as the airline buys a Rolls Royce engine, we secure a service package with them, sometimes for as long as 20 years, where we will provide all the maintenance, all the spare parts for their engine. We will make sure they have engines available whenever they need them to support their aircraft, and they simply pay for the number of hours they fly.
At peak times, the team may be monitoring engines carrying 400,000 passengers.
We're sort of watching in the region of 8,000 to 10,000 engines, 24/7, 365 days a year.
Well, and that's the question, is this pretty normal or is it not?
We're looking at speeds, pressures, temperatures. We're just nipping problems in the bud before they happen, so people aren't waiting around in airports for the flight that's been cancelled or delayed again. So that's ultimately what we're trying to do.
The centre receives 1.5 million measurements every day, from anything up to 1,200 Trent engines at a time.
Typically a minute after the aircraft has sent that information, I can see it in graph form.
The data is analysed by computer, and if any unusual readings are detected, the engineers are automatically alerted.
Probably 95% of them we can very quickly sort of work out that there's nothing to worry about.
All the help desk engineers are experienced enough to solve any problem that might crop up.
I worked with Rolls Royce engines hands-on, mainly in the Royal Navy for 13 years.
And they're just a phone call away from maintenance crews at key airports around the globe.
Yeah, I've just had an email if he's asking for data going back to January 2009, LP vibration data. Do you think you could answer that?
Back on the assembly line, this Trent engine has hit a problem, just 1 week away from its completion. The final module needed for the vertical stack has been held up on its way from Europe. Without it, the stack can't move along the line.
It's a turbine which actually drives the big fan at the front of the engine, which is mounted inside the fan case.
The engine is stuck in the assembly tower, but the fitters can't afford to lose any time. Instead, they've identified parts that can be fitted ahead of schedule.
It could arrive any time in the next hour, it could be in the next day, you know, we don't really know. So what we've done, we've jumped ahead and carried on building to try and get things done. As it is at the moment, we can't move it, we can't pick it up without that final module.
Any hold-up in the production process could cost money, so tracking down a replacement module is critical. And Kath Taylor is straight on the phone.
Can you guarantee that it will reach us before 6 a.m. in the morning? Yes? Yes.
At long last, it does arrive. And even though it's the middle of the night, the build will carry on. Working through the night is part of life for everyone on the production line. In Warwickshire, father and son Bob and Lee Blackwell are starting another night shift at the fan case factory.
It takes a bit of getting used to the body clock. It's quite hard. By Thursday, you're sort of ready for the weekend to catch up on your sleep. We tend to work the same shifts. On nights, we tend to get on each other's nerves. It's a testing shift, you know what I mean, when you're tired.
Tonight, they're working on a new fan case, bigger than any other, to be fitted to a new Airbus that is currently being built.
This is the biggest component that we've actually manufactured to date, 118-inch diameter, so it's a challenge. I mean, this is something that we're really proud of as an organisation. It's a first in everything that we're doing at the moment.
It won't be long before these parts are put together to make the first complete new fan case. When finished, it'll be the biggest Trent engine of all, with the lowest carbon emissions, and could become the third Trent engine in a row to launch a new jumbo jet.
It has actually been the fastest selling Trent engine in history. We already have orders for 1,000 Trent engines, and we will build that early next year. We will start testing it, and we'd hope to see it in the skies about 2 years from now.
But investment in new technology is worthless without investment in new people to keep manufacturing skills alive.
I'm currently an apprentice at Derby at Rolls Royce as a manufacturing engineer in engineering maintenance.
Apprentice schemes like this are vital to British industry.
This is rotatives, this is my business that I'm working in. They mainly, again, deal with the discs, drums and shafts. I mean, here we've got mainline shafts, so this is where they build the largest shafts which go through the main part of the engine. These are the coverings that go around them, so to make sure that the parts don't become damaged. You've got the various drilling machines down here. And then as you walk through here, this is where I work. This is the shaft supports office.